Hi, in this video I'm going to solve the second example for next net change theorem. It starts with actually the same setting from the previous example. It's just a ball thrown up with initial velocity of 96 feet per second, and its acceleration from gravity is negative 32 feet per second squared. Now the question here is, what is the net change in position between 0 and 6 seconds? So we're going to be using here this statement that stands for the net change theorem. So we say here the integral of the rate of change, the f prime of a function, will lead us to the net change for whatever the function is standing for. So in this case, following up this diagram, what is the derivative of position? Well, the derivative of position, of course, is velocity. So given the context of this example, what we will be looking for will be the integral between 0 and 6 seconds for velocity with respect to time, and this will lead us to the net change in position, which is s will be s of 6 minus s of 0. Now the thing is, we have to look for what actually is this velocity. So let's look for it. I'm going to solve it. From the previous example, we found that the function for acceleration with respect to time was actually a constant function, which is was negative 32 feet per second square. And so I'm going to skip using the unit just to write it quickly. So if we integrate, we take the antiderivative of acceleration derivative like this, its antiderivative would be the velocity plus a constant. Now we have to find basically this, so let's look for it, and also of course we have to look for c. So let's see, I'm going to solve it in using, let's see, this color. So well, the antiderivative of negative 32 dt, this would be equal to negative 32t plus c. Now this expression is actually, it's already what we're looking for velocity, but it's not complete. So this is velocity with respect to time. It's equal to negative 32t plus c. So in order to find c, we require a piece of information, and given the data we have from this setting, we have here that the initial velocity was 96 feet per second. In other words, we're saying that velocity at the time equal to 0, what's equal to negative 32 times 0 plus c was equal to 96 feet per second. So we can cancel out the first term like this, and we found that c is equal to 96 feet per second. So with this, we actually have the full expression for velocity. This one will be placed over here. So we can actually just aim to solve this problem now. I'm going to use let's see, there it is. So actually the integral between 0 and 6 for velocity, I'm going to use a parenthesis here. There it is. It's going to be negative 32 times t. It will be plus 96, which is, we are substituting in here what the values for c that you found, be dt. Now let's see, the antiderivative of this term will be negative 32 t squared over 2 will be plus 96t. This will be evaluated between 6 and 0. So this will look like this. We can simplify this out. This we can take half of 2, 1, half of 32, 16. So it would be negative 16t squared plus 96t, and we have to evaluate between 0 and 6. So let's see, let's evaluate. I'm going to use brackets to do it with more order. It'll be negative 16 times 6 squared will be plus 96 times 6, and will be minus, will be, well, of course this will all cancel out the second term. I'm just going to write it for you see the whole detail of it. Be here 0. This is a very ugly bracket. There it is. So we sort this out, and of course this whole term will cancel out. Let's see. I'm going to use a calculator here. Here we got this is equal to negative 576. This we are multiplying here we are multiplying here. I'm going to use another color for the units. We multiplied here meters. This is meters per, it's feet per second squared, I'm sorry. Feet per second squared times, this will be seconds, but this seconds was squared. So will be times second squared. So these two units will cancel out the seconds. Cancel out the seconds here and here. And let's see with the other one, we are multiplying here feet per second, and with this 6, it's 6 seconds. So we are canceling out as well the seconds. Remember, it's very important this problem is that units actually make sense. So this is negative 576 feet. Now, this multiplication, 96 times 6, it's equal to actually plus 576 feet as well. So you can see we can cancel out these two guys. We can cancel out these two guys, and we got the result is actually 0 feet. Now, what do this? What's the meaning of this? What's the question was, what is the net change in position between 0 and 6 seconds? So if we have that the net change in position was equal to 0 feet, that is to say that we got back to where we started. As you can see here from the cool diagram I draw here on the left, the ball that you're throwing up is going to eventually come down. So this is a time 0, and here is a time 6, and that's what happened. That's why the net change in position is equal to 0.